Continuing our coverage of the mechanics of capital budgeting, we look at 3 remaining metrics and their usage: modified internal rate of return, regular payback, and discounted payback. Here are the 2 sample projects we're using to demonstrate the various methods. Remember we said that NPV dominates even if the result conflicts with another method. Let's explore how those conflicts can occur. Still using our 2 sample projects, L and S. The table shows the NPVs for both projects at varying cost of capital values. At low rates, Project L dominates. At higher rates, Project S appears better. The crossover rate is the discount rate where the NPV of the 2 cash flow streams are the same. To find the crossover rate, we'll use that change in cash flow column from an earlier slide and repeat it here. In this example, we subtracted S's cash flows from L, but it doesn't matter which way you subtract. Enter those cash flows in the CF worksheet and solve for IRR. The result is the crossover rate. If arrow displays, the profiles don't cross, so there will be no conflict. If the cost of capital is less than the crossover rate, then NPV and IRR results can conflict. If the cost of capital is greater than the crossover rate, no conflict. What makes the profiles cross? Size or scale differences. One project involving significantly larger cash flows than the other. Timing differences. That's the case with our 2 projects. One generates larger cash flows sooner. If projects are independent, NPV and IRR always lead to the same accept-reject decision. If projects are mutually exclusive, if the cost of capital is greater than the crossover rate, no conflict. If it's less, you'll have different accept-reject decisions. Let's look at the problems with IRR mentioned in Part A. The IRR methodology has 2 serious issues: the reinvestment rate assumption and multiple IRRs when you have non-normal cash flows. NPV assumes investment of inflows at the cost of capital, while IRR assumes reinvestment at the internal rate of return. This means if the IRR is 25%, inflows are reinvested at 25%, which probably overstates the internal rate of return. Reinvestment at the cost of capital, a market rate, is more realistic. NPV should always be used to choose between mutually exclusive projects. Perhaps there's some hybrid that we can look at that will give us a percentage like executives like. In solving for IRR, we're solving for the root of an n-degree polynomial. Descartes' rule of signs says that there will be one real root for each sign change, with the remaining roots imaginary. For a project with non-normal cash flows, that means for each sign change, you can get a real solution to internal rate of return. A solution to both the reinvestment assumption and the multiple IRR issue with the IRR method is to use the modified internal rate of return. MIRR allows the reinvestment rate to be specified so the opportunity cost is equal to the cost of capital. MIRR also avoids the multiple IRR problem. Managers like a rate of return, and MIRR is better for this than IRR. The formal definition is on this slide, but it'll be more useful to see this charted. Using Project L as our example, our first step is to find the future value of all inflows, all positive cash flows. Note that the TI Business Analyst 2 does not solve for the future value of an uneven cash flow stream, but it's easy to find it in your calculator, which is covered in the MIRR video tutorial. In this example, the CF1 of $10 is future valued 2 years, so 10 times 1.10 squared. The $60 is future valued 1 year, and the 80 is already at the end of the timeline. These are added together to find the terminal value. We need to find the discount rate that will grow the $100 outflow at time 0 to the terminal value of inflows of 158.1 in 3 years. The Excel function for this requires 2 rates: a finance rate, which is the discount rate, and a reinvestment rate, which is the future value rate. For all of our uses, we'll use the same rate. You can solve this with the TVM keys, as you can see in the small inset and on the next slide. Enter the values in the TVM keys. N is 3, present value is a minus 100, Payment is 0. Future value is the terminal value of inflows, 158.1. Compute IY, 16.5. And you can see the dedicated Excel function at the bottom of the slide. As an example of multiple IRRs, suppose we have the Pavilion project. At time 0, we need to invest $800,000 to build a World's Fair pavilion. During the fair, we estimate we'll make $5 million, but it will cost us $5 million to put the land back like it was after the fair closes. These values are shown on the timeline. Solving for NPV, we get a negative 386,780, but the IRR results in an error, 2 sign changes. Here's a look at the results of our Pavilion project. At very low discount rates, the present value of CF2 is large and negative NPV. At very high discount rates, the present value of both CF1 and 2 are low, so CF0 dominates. NPV is negative. In between, the discount rate hits CF2 harder than 1, you got a positive NPV. Result, 2 IRRs, 25% and 400%. 25% is possible, 400% is clearly not. Now that we see how MIRR works, let's revisit our Pavilion project as it illustrates an important point about finding the values to use to find MIRR. All outflows are present valued back to time 0 and sum to use as the present value. Outflows to the left on the timeline. All inflows are future valued and sum to use as the future value. Inflows to the right on the timeline. With the Pavilion project, we have 2 outflows, time 0 and time 2. The cash flow at time 2 must be discounted back to time 0 and added to cash flow 0, which results in a negative $4,932,231.40. Future valuing the $5 million at time 1, you get $5,500,000. Putting that in your calculator, N is 2. Present value is the negative $4,932,000, etc. Payment is 0. Future values, the 5.5 million. Compute IY, 5.6%. When do you use it? Anytime you have non-normal cash flows, more than one sign change. For our Pavilion project, with an NPV of a negative 386 and an MIRR of 5.6% against a cost of capital of 10%, this looks like a no-go. This would be an opportunity to consider that the firm may well decide to go ahead with the Pavilion anyway, knowing that they'll lose almost $400,000. They may decide it's worth it for strategic reasons. Do you think McDonald's going into China was a positive NPV project? Probably not, but they went anyway for the strategic advantage. If MIRR still sounds a bit confusing, watch this video tutorial which walks through it step by step. Our last 2 methodologies are payback and discounted payback. Payback is the number of years to recover the project's initial cost. It's one of the easiest to understand metrics, so we'll walk through an example. Using Project L again, accumulate the cash flows from time 0 to the last year. We're looking for when the sign of the accumulated cash flows changes from negative to positive. For Project L, the sign change occurs between years 2 and 3. A fundamental assumption in finance is that cash flows occur at the end of each period. But in this case, we assume they are evenly spread throughout the year. So we want to know how far past year 2 toward year 3 we have to go to exactly pay back our initial investment. The logic in this example is that at the end of year 2, we're still short $30. But by the end of year 3, we earn another $80. So how far into that year do we have to go to cover the $30? We find the fraction by dividing the last negative cumulative cash flow by the cash flow in the next year and taking the absolute value. In this case, that's the absolute value of minus 30 divided by 80, 0.375. Add that to the last year with a negative cumulative cash flow, and you have payback, 2.375. Repeating the process for Project S results in a payback of 1.6 years. One major problem with payback is that it ignores the time value of money. Discounted payback solves that issue. Technique is the same, except the cash flows are discounted before they're accumulated. Two things to note. Discounted payback will be longer than payback. The sum of the discounted cash flows will always equal NPV. Both paybacks do give an indication of risk and liquidity, which may be critical, especially to a smaller firm. Payback is easy to calculate and to understand, almost a back-of-the-envelope metric. However, regular payback ignores the time value of money. Both paybacks ignore cash flows after the payback period, which biases the result toward projects with larger cash flows earlier on. The main problem is it asks the wrong question. We're looking for projects that will increase the value of the firm. Payback measures when we get our investment back. Discounted payback does use the time value of money, but the other issues still exist. This video tutorial covers NPV, IRR, payback, and discounted payback. In summary, with today's computing power, it's easy to calculate all the metrics. While NPV is the dominant one, each does provide valuable information. NPV is a dollar value and indicates the expected increase in the value of the firm. IRR is a percentage and gives you an indication of risk. MIRR is also a percentage and corrects problems with IRR. Payback and discounted payback are in years, and they indicate liquidity. This ends our coverage of capital budgeting methodologies.